Good evening, everybody. Today, I'm going to be presenting this topic with my partner Jaden Green. And before I also go forward, I go by the name of Obina Eze. So, what we're going to be talking over today is 3D printing. So, without further ado, we're going to begin. So, to give you guys an overview, the process of 3D printing, also known as additive manufacturing, is by which physical objects are created by dropping off materials and layers based on a digital model. With at least 40 years of history documented, three-dimensional printing technology is presumed to resolve the drawbacks that are undoubtedly faced when implementing traditional methods. The starting point for any 3D printing process is a 3D digital model, which can be created using a variety of 3D software programs. So to go over the materials, we have conventional thermoplastics, ceramics, graphene-based materials, and metal. As for the pros, we have production speed increase, cost reduction, consumer power by the means of input on construction, safety and reliability goes up, the environmental pollution is lowered, and lastly, the versatility in product design and structure. Now, with every good project management, you always want to have a schematic involved, and that's where building information modeling comes in. So understand that the goal is to facilitate a more cohesive plan and construction process, as well as forming substantial benefits with minimal mistakes and efficient production. To explain, BIM, you can also say that's BIM, is a digital representation of physical and functional characteristics of a facility, creating a shared knowledge resource for information about it, forming a reliable basis for decisions during its life cycle, from earliest conception to demolition. With that in mind, I also want to take this time to mention the industry foundation classes, which is known as an international standard for the exchange of BIM data, which provides a generic data schema covering, among others, architecture, building service, and structural elements. IFC specifies data representation and file format in the following: Express Data Specification Language, XLM Schema Definition Language, clear text encoding of the exchange structure, and lastly, extensible markup language. Now, I want to also take this time to go over the process of 3D printing. So what I just showed you in the last slide was just the schematic mentality behind it. Now, here is the list along with the breakdowns on a few certain topics. So we have the building information modeling, then which is followed by stereolithography, also known as STL. Next is slicing, followed by layer combine. When you knock out all these four, then we get into the 3D printing process, and which is where it ends off with the formation of our so desired object. Now, I also want you guys to understand that the STL format, which in the acronym stands for Standard Tessellation Language, only utilizes the three-dimensional description of the surface geometry without generating non-relevant information for printing, like texture or color. Along with this, most models for 3D printing are in these particular formats. Now, in the slicing step, the geometric model is intersected with parallel planes to obtain the contour of each material layer. And then to explain the layer combine, the combining of different polymers in different combinations per layer of 3D printed material is leading to the development of an entirely new palette of materials. So as an example, you'll always hear about the samurai and how they dress, how their culture was, but most importantly, how their weaponry was at that time period. And one of the special things about the swordsmiths at the time was that when they were creating these blades called katanas, it was made out of mixed materials for its curved shape. Now, one of the last things I'm going to talk about before I pass it on to my partner is pretty much the contribution that 3D printing has to society. Now, I want y'all to also understand that the preparation of organ models, rapid manufacturing of personalized scaffolds, and direct printing at the defect site can be achieved by 3D printing technology based on a patient's imaging data, such as CT or magnetic resonance imaging. Currently, 3D printing is primarily used for producing artificial heart pump, jewelry collections, 3D printed cornea, PGA rocket engine, steel bridge, which can be found in Amsterdam, and other products related to the aviation industry as well as the food industry. With that in mind, this leads into the topic of how there is a growing demand for the development of customized food for specialized dietary needs such as athletes, children, pregnant women, patients, and so on, which requires a different amount of nutrients by reducing the amount of unnecessary ingredients and enhancing the presence of healthy ingredients. So thanks to this form of manufacturing, there's now implementation to print 3D skin, drug, and pharmaceutical research, bone and cartilage replacement tissues, organ, and printing for cancer research. 3D printing technology can be used to create everything from prototypes and simple parts to highly technical final products, such as airplane parts, life-saving medical implants, automobile, and even artificial organs using layers of human cells. To add on, we now have models for visualization, education, and communication. Now, before computers took over at the end of the second millennium through software for computer-aided design and manufacturing, the creation of solid objects usually involved disassembly material from an assigned block. That is until the structure was acquired, of course. To the public eye, this form of fabrication was considered subtractive. In contrast, 3D printing was additive. To elaborate on this pivotal invention, the increasing computation power at decreasing cost was offered practically to each engineer, a trend towards diffusion and, so to say, democratization of computation and communication resources. So to list all the inventions that we have listed, there is the first functional kidney printing in 2002, followed by the first self-replicating printer 3 years later, and then another 3 years later we have the first 3D printing prosthetic leg, and then a year later we have 3D bioprinting using a patient's cells to produce blood vessels, and then throughout the following years we have the first 3D printed UAV or unmanned aerial vehicle, the first car with a 3D printed body, zero gravity onboard 3D printer, food printing, and lastly, the first 3D printed cement that was stuck 3 meters high. So on that note, I would like to pass it to my partner, Jaden. So without further ado, take it away.
Cool. So now we have next slide. Cool. So now we have the types of 3D printers. So first, let's talk about the SLS, which is selective laser sintering. This is a technique for binding material together with the use of a laser sintering the powder material. And this powder material is nylon 12. And basically what sintering means is binding together. So when we have SLA, which is stereolithography, it's a much less powerful technique than SLS. It focuses more on non-metals like polymers and resins, while SLS focuses more on metals. And how the process works is basically when you have well, just like how my partner said, when you have a 3D printer at the bottom of it, well, at least when it comes to these SLS and SLA printers, The bottom, you will either have a resin or a powder surface, and at the top, you will have the laser, and then that laser will be pointing its UV light towards a mirror, which will reflect that light down to the surface, which is the resin or powder surface. And instead of burning it and liquefying it, it has a sintering effect, which then binds the powder or binds the resin together, and it creates a pretty durable and firm material. So then after that, we have the triple F, which is fused filament fabrication. This is continuous filament or fiber extracted from a heated printer extruder head. FDM, which is fused filament modeling, is the same thing, but used more in the industries due to its requirement of high quality. And as we can see in the picture, the bottom where the red surface is, that's where you could put the resin or the powder. And then we could see the yellow, that's the laser, the black square, the mirror. And it's just a simple process, but you could do a lot with it. Next slide, please. Cool. And now we have the discovery of 3D printing part one. So thanks to the engineers J.T. Parsons and P.T. Hennerty, the numerical controlled manufacturing was formulated and became the one of and became one of the persec- pre- precursors of innovation. In the last half of the 20th century for the USA, additive manufacturing was mainly utilized for the creation of microchips or electronic circuits fused onto flat silicon wafers. It wasn't until around the 70s and 80s that a rise in widespread propositions behind multitasking, computer aided fabrications became normal. From decades onward, product design diversified. Next slide, please. And then we had the discovery of 3D printing part two. It all started with an amusement of creating materials at a rapid pace. The idea was to layer liquefied metal and create a design before it dries. Wax and metals were the first prototypes of its source. In the 1980s in Japan, Hideo Kodama was one of the first inventors, and he did this by making it from a photosensitive resin polymerized by UV light. Next slide, please. Thank you. Now we have 3D print evolution. Just like how we said before, Hideo Kodama was one of the first inventors of a rapid prototyping system in 1988. In the same year, we have Charles Hull, and he was the first to go commercial with the SLA 3D printer, which was called the SLA 1. And it was accomplished by curing photosensitive resin layer by layer. Finally, a couple years later, well, not finally, but a couple years later, we have Carl Decker. He developed the most common form of 3D printing we see today, fused filament fabrication, known as triple F. And as we can see in the pictures, that's a picture of one of the triple Fs, and that's a picture of the SLA, the white one and that one. And then next slide, thank you. Cool. So now we have the RepRap project. So with this, we have Dr. Adrian Bauer. He was the founder of this. And in 2001, he had two machines, two 3D printers to be specific. One was a $50,000 printer, and the other one was a $300,000 printer. And with this, he was hoping to accomplish the miracle of creating another 3D printer. And finally, in 2005, he was able to do so. And to get one today, I say it would cost around $200 to $1,000. And Dr. Adrian Bauer, he even open sourced it because he felt it was selfish not to allow people to do what the machine is made to do. So with the open source project, it enabled anyone to use, study, or even modify the project. And it even became the leader of all printer manufacturers. And as we can see in that model right there as well, that's a picture of what is known as the 3D printer, or one of the first 3D printers capable of printing another.
We have 1 minute and we hit 15 minutes. Continue.
Cool. So 3D printing today, we have a couple benefits. So flexible design. This flexible design gives access to a variety of complex creations. Print on demand.
Speed up a little bit faster.
So with the print on demand, all design files are in a virtual library, giving users access when needed. And then the price effective, the labor. You don't have to do anything with the labor because once you create the machine, it could do it by itself. You don't have to, not once you create it, once you start it, it could continue the process. And then advanced healthcare, seen in the healthcare because you could create a lot of organs with it as well. Well, you're seeing a lot of printed organs with it. And then finally, we have the, not finally, but then we have the future of 3D printing. More efficiency, so that could be seen in the future for faster creation rate, better running systems,
And next
and
slide.
then the disadvantages of 3D printing. The number one is copyright, and it could be loss of jobs. And that's it.
All right, that's time. Appreciate you guys for attending, and I hope you guys learned something from this. Thank you.